A great way to visualize what happens with different bases is to see it from a visual perspective. So I've got a GeoGebra applet here that will allow us to look at different bases within the same rectangular coordinate system. So we've got a vector here that's going to the point 2, 2. So this is the vector 2, 2. And I've done my best to align these vectors with the standard basis. So we've got a couple of vectors down here and here that represent, in this case, a rough approximation for what the E1 and E2 vectors would be for the standard basis in R2. So the benefit here is that this would be the coordinates, 2, 2 would be the coordinates for this particular point, as long as we are in this particular basis or working with the standard basis. If we decide to work with a different basis, I think the really important part to recognize from a visual perspective is that changing a basis is really about kind of moving these axes a little bit, if you will. And we can even see our standard grid, noting the point 2, 2 on the grid. But we can also display the grid that's associated now with our new two basis vectors that sweeps out the same plane, in this case, the entire xy plane. And as we change the two basis vectors, we can see how the grid is changing specifically around that. So what's happening, as you notice, when we change the basis vectors, although the measurement system is changing, the individual point out here that we originally started with, that point is not changing. Its relative position to the origin has not changed. It's just the way that we're measuring that particular point that's changed. So I can manipulate this basis so that effectively it turns into the point 1, 1 under this new basis. You can see it's intersecting at the first box there, at the corner of the first box, if you will. So now under this basis, that point is at the point 1, 1. And this is really what happens when we change bases, is you're just changing the measurement system, but the relative position of a point stays the same. And we can see this with another GeoGebra applet that I'll bring up here. So here we have a plane in R3. So this is our subspace. And within that particular plane, we've got a couple of vectors that represent our basis and a particular point, this green point here, that represents some point in R3, but is on or rather in our subspace. And we could describe that by decomposing its vector into its horizontal and vertical components. In this case, again, the coordinates for the point are all relative to the particular basis that we're working in. So we can try and align this to some extent to what would appear as some kind of a familiar kind of right angle type I and J components, if you will. That looks pretty close. So that's almost kind of a square box. So we could then describe this particular point, and I could put this point at a particular space here, and that looks kind of like it's at the position it is there right on that intersection. But of course, the idea here now is that it's only at that particular coordinate in 3 space relative to this particular basis. If I were to change the vectors here a little bit, then the coordinates for the point change because the measurement system has changed. Down here below, we see what the basis vectors are. And as I move these, you can see that the basis will change relative to where I put these two vectors. So these vectors are changing. This is your basis. Again, that's sort of designating the way in which we're going to measure getting from one place to another on our plane. And above here, I'll scroll down just a little bit so you can also see this. We've got our basis vectors, and then we've also got what is a coefficient in front of those basis vectors. And it's these coefficients that represent what the coordinates are. They've rewritten them out back. It really shouldn't be equal to these things, but it should be an implication that these are then the coordinates for the particular point with respect to the particular basis that we're working on. Again, we can change these points or rather change these basis vectors, and that's going to change the coordinates that we get. So again, the idea with the basis is it's just a measurement system within the subspace that we're working on. And those two vectors are going to define for us what our grid is going to look like, how big it is, and so forth. And then again, the coordinates for any point or vector for that matter in that subspace is all relative to that measurement system. So it's relative to that basis.